Writing generic methods. In the previous section, we saw how to write parameterized classes. Now, let us spend time in exercising parameterized methods or generic methods in this section. A generic class contains a type parameter affects the entire class. But a generic method containing one or more type parameters affects that particular methods only. So, it means that a non-generic class can contain a mixture of generic and non-generic methods. Following code snippet shows how to declare a generic method. If we look at the way in which a generic method is declared, we find that the static method printType has a return type void and it takes a single parameter called t. Here, t stands for any parametric type which can be substituted with any of the Java types by the clients. Since we have introduced a parameter t, it should be defined. But where? It should be defined in the method definition itself just before the return type of the method, t. The moral is, whenever we have different type parameters in the method, it should be defined in the method's definition. For example, consider the following method that has two type parameters a and b, and they are defined before the type of the method separated by commas. But the same type parameter can be used multiple number of times in the parameter list. For example, the type parameter a is defined once but used multiple times in the following code. Wildcards. The following section explains the usage of wildcard characters in the generics. For example, consider the following. List string str objects equal new array list string. The above line declares an array list with a type being the string type. The declaration says that the list str object in this case can hold objects only of type java.lang.string. No other type is permitted other than java.lang.string. So, the following statements are legal as they are adding objects of type java.lang.string. Now, consider the following assignment statement which assign the object reference str object to another str objects. Now, another str objects is pointing to the str object's reference. The above is perfectly legal statement as the assignment happens between the same type. Now consider the following. The above statement will lead to a compiler error telling that cannot convert the list string to list object. Though string is a subclass of the object class, this type of conversion is not possible in generics, but the following code compiles well. The reason why it is not possible to assign the list containing a string to a list that can hold objects can be given justification as follows. The main goal of having generic code in a program is to ensure type safety. It means that the expected application types and the types sent by the clients could match. There should not be any deviation or mismatch in their types. If we go back on the code, on the left hand side we have a list that hold objects represented by list object objects. This tells to the compiler that this list can hold objects of type java.lang.object. Now we are making this object list to point to some other list whose parametric type is string. Thus string is a concrete subclass of object. This assignment is not possible. Let us see how to get over this problem. Consider the following code. List objects equal str objects. The character question mark is a wildcard character and it stands for any Java type. It can be java.lang.object type or some other type. It is just a placeholder that tells that it can be assigned with any type. Considering in this case, the following are not valid syntaxes. The above code is nippers trying to assign a list of integers and a list of doubles to the reference any objects. This is perfectly legal. Another strange thing has to be considered is while adding elements into the collection. Since the type parameter for the reference any object is no object can be added to the collection, not even java.lang.object. The only exception is that only null can be added to this type of collection.